the correlation between the variables x and y was actually 1, and one of the students, he actually told me that was that was the value that the student obtained. The student Dipanjan has told me that he has got the value 0.992. Now let us figure out whether he is right or wrong. If the student has got this value, then I do not have any problem, because 0.992 can be approximately equal to 1. Probably his value is 0.992 because he has not considered sufficient number of sufficient number of digits after decimal point. Okay, if you consider sufficient number of digits after decimal point, then you are going to get 1 over here. 1 is actually the answer which we actually want for this particular problem. Why? I'm going to tell you why. Because initially when I set the problem, I knew the answer has to be 1. But if the student, this is the first thing which I got in the chat box. I have got this result from the chat box. I also got from the same student that he said that probably he has got the answer to be 1.24. If he says that he has got this answer 1.24, then he is wrong. Why? Because there is a limit. There is a limit of the value of the correlation coefficient. There is a limit. And what is that limit? What is that limit? If correlation coefficient is denoted by R, if the correlation coefficient between the two variables is denoted by R, then it should be greater than or equal to -1, and it should be less than or equal to +1. So you cannot have R which is less than -1. This is absurd. You cannot have R which is greater than 1. That is also absurd. This is the limit of correlation coefficient. Okay, so therefore I have said that if the student has got 1.24 which is greater than 1, his value is wrong. It cannot be. But if he has got 0.992, that is maybe he has not considered sufficient digits, and we will say that it is all right, because if 0.992, if we consider 0.992, that is less than 1, so we can consider 0.992, but this is not acceptable. Now I am going to talk about how did I know that the answer to the given problem, is going to be 1. I'm going to talk about that. Okay, so let's find out why it is 1. Now when I set the problem, what values I actually gave it to you? I gave the values 1, 2, 3, 4, and I gave the values y, which was 3, 4, and this was 5, and that was 6. If you carefully observe, you see that when I wrote this value 3, that was actually equal to 1 plus 2. That 1 is the value of x. When I wrote this 4, that was actually 2 plus 2. When I wrote 5, that was actually 3 plus 2. When I wrote 4, that was 6. It was actually 4 plus 2. So actually my y has been set to the formula y equal to x plus 2. Y equal to x plus 2. Okay, this formula I have used. It say linear equation. This equation is called linear equation. Why it is called linear equation? Because the power of the variables present on both sides of the equation where 1. Here, that means here y has power 1, here x has power 1. Okay, so therefore this such a equation is called linear equation. And you see, if you plot the figure, if you plot it, suppose this is your capital X, that is your capital Y, and let us plot these points. Okay, so if this is your 1, that is your 2, that is your 3, this is your 4, and similarly we get this to be say 1, this to be 2, this is to be 3, this to be 4, and let me write two more points. Okay, so let us increase this particular thing a little bit, and that is your 5 and that is your 6. If the points are like that, and if you plot the points, and let me rectify this. So this is your 1, and that point is your origin. If you want to plot this, then what you get? For 1 you are actually getting 3. Okay, for 2 you are actually getting 4. For 3 you are actually getting 5. For 4 you are actually getting 6. Let me draw it properly. Okay, and this is nothing but a straight line. This is nothing but a straight. Actually we are actually getting a straight line. And the value, the correlation coefficient between the correlation coefficient between them is equal to was 1, and that is positive. It is a positive correlation. The value is positive. This means, and which is also clear from the figure. Okay, Dipanjan wants to say something. Okay, chat is open, right? Dipanjan, what do you want to say? Write in the chat box. This means that when capital X is increasing, capital Y is also increasing. Capital Y is also increasing. So both are in increasing direction. Both are in increasing direction. Yeah, the line of origin should be from 0. Yeah. No. You have not got my point. Since my drawing of my diagram is wrong, I mean, it was not like, actually, I'm not using scale. It will go like this. It will go like this. Okay. So this equation should always not be through the origin. Okay. So for example, if you have got 2 value for 1, for 1 we have got the value 3, for 2 we have got the value 4, for 3 we have got the value 5 and 6, like this, then this will not pass anyhow. This will not pass through the origin. I am going to show that to you graphically with the help of the software right now. Right now I'm going to stop the share of this board work, and I'm going to share the Excel sheet where I'm going to show you how to calculate the correlation coefficient between the two variables using the software. Because you have now learned how to calculate the correlation coefficient between two variables manually, so you have the right to know how to use the software to calculate the correlation coefficient. Without manual calculation, you are not supposed to use the software. When I shall use the software, then you will get to know, you will get to see the diagram clearly and how it passes along the lines, along the points. Okay, you will get to know, Dipanjan. Let me talk first of all. So we have got a positive correlation, the value of 1, and value is exactly equal to 1, and therefore it says that the x, when x is increasing, y is also increasing. One important point to be noted, we know that the correlation coefficient between the two variables lie between -1 and +1, but when the correlation coefficient between the variable is exactly equal to 1, we call it perfect positive correlation. And when correlation coefficient between the two variable is equal to -1, we call it perfect negative correlation. Okay, so we actually use the term perfect positive correlation and perfect negative correlation. Otherwise, again, when correlation coefficient between the two variable is positive but not equals to 1, we only say positive correlation. We do not use the term perfect positive. We use the term positive correlation only. Okay, and when Rxy is less than 0 but not equals to -1, we only say negative correlation, and we do not use the word perfect negative correlation. So you have to know the difference between among these terms. When Rxy is equal to 0, we call it no correlation. And this point is very important. It needs lots of discussions further. Okay, so I'm going to talk about this particular point later on. So you get to know these terms: perfect positive, perfect negative, simple, only positive, only negative correlation. Now I'm going to stop sharing the whiteboard, and I'm going to share the Microsoft Excel, where I'm going to calculate the same thing using the software, using the Excel software. I hope that you will get to know what is happening. The manual calculation will be checked. Many things will happen when I use the software. First of all, you will get to know how to use Microsoft Excel to calculate the correlation coefficient between the two variables. You will get to see how the scatter diagram, the plot, is actually moving, increasing direction or decreasing direction, and also my calculation will be checked whether I have done it correctly or not. Okay, so let's see what my software is giving me, whether it is giving me 0.992 or 1. Okay, so okay, so here is my Excel sheet where I'm going to show you the calculation using the Microsoft Excel. The same problem. I hope that you are able to see what I'm sharing right now. So just a minute. So what was my variable? My variable was capital X, and my other variable was capital Y. Sorry, it has become T. Capital Y. And what were the values for capital X? The values were 1. Then we had 2. Then we had, sorry, this value was 2. Then this value was 3. Then this value was 4. Sorry, 4. Okay, these are the 4 values we considered. And for capital Y, the values were corresponding to 1, it was 3. Corresponding to 2, it was 4. 2 plus 2, 4. Corresponding to 3, it was 5. And corresponding to 6, it was 4, it was 6. These are the values which I used for solving to find the correlation coefficient. And I have selected the entire chart, and let me put the borders like this. And just a minute. And again, I'm going to select this chart, and I'm going to go into the section which is called insert. From there, I can select this particular thing which is called scatter. I'm plotting the figures. This is called scatter diagram. And you see, I hope Dipanjan is now able to see what is being shown over here. Dipanjan, you have got your scatter diagram. So this is the movement. You see, imagine a line is going through them, and that line is actually passing through very near to 2, but it is not passing through origin. Origin is left below. Dipanjan, origin is left below. Can you see it? Okay. Now, so we have got our scatter diagram, and I told you in my earlier class that before you find the correlation coefficient, it is a good practice to, and it is actually needed. You are actually supposed to see the movement through the scatter diagram. If the movement is not seen through the scatter diagram, it is not expected to calculate the correlation coefficient. First of all, see the graph and then find the correlation coefficient. By looking into the graph, anybody can say that, yeah, the movement is positive, in positive direction. When capital X is increasing, capital Y is also increasing. For the increase in capital X, there is an increase in capital Y. Okay, so obviously we know there is a correlation, positive correlation. We want to know what the value is. So to find the correlation coefficient between this, what we do, we select a cell. We select a cell like this, and we, just a minute, we put equal to sign there, and then we write, actually, I don't know if I write it in this manner, suppose it will not work. So let me use it properly. What we do, we actually select this particular cell, any blank cell, we put equal to sign, and then we go to this section, which is called formula section. For formula section, we are going to calculate this more functions, and from there I'm going to select statistical. And you see, in this, under this statistical, you have several formula. One of this formula is called Codel. Now this is your array 1. Array 1 stands for the variable x and array 2 stands for the variable y. So I'm going to select the data present in capital X. Okay, first of all. So my data starts from here. So I have selected all the datas, and then I'm going to select the data for array 2, and that is this. Sorry. Just a minute. So this will be like this. Okay, you see, I have selected the data, and you see what you see over here. Put enter, and then you see the correlation coefficient between the two is coming out to be 1. The correlation coefficient between the two is coming out to be 1. Okay, I'm again showing you the calculation. So what I am doing here, I'm selecting one blank cell. I'm double clicking it. Somebody is writing something. Okay, so I'm selecting a blank cell. I'm double clicking it and putting equal to sign. Once you put equal to sign, that means your formula section is open. Then you go to this particular part that is besides the page layout. It is called formulas. From under formulas, you are going to select more functions, and under more functions, you are going to select statistical. Several things are there. You can see engineering is there, cube is there, information is there. I need to select statistical. And under statistical, you have to select correl. Correl stands for correlation. What is written over here? You read. Returns the correlation coefficient between the two sets. Click on it, single click. After clicking this, you see that two arrays are being shown. One array is for one variable, another array is for another variable. And we are going to select array 1 for capital X and array 2 for capital Y. And in the box also, you can see that 1 is present over here. Okay, if I click enter, then correlation coefficient is 1, which shows the perfect positive correlation between the two variables, and which justifies my calculation that I did in that justifies my calculation that I did in my board work. Okay, so that is the thing. I hope that you have understood. If you have Excel, then I'm going to in the next class. In the next class, it is better if you are using your desktop or laptop. It is better if you open your Excel sheet. Then I can show you. I can present you a problem. I can show you the problem sheet, and from there, by taking the data, you can do the practical calculations by yourself. It will be a good practical application of the statistics. By using your Excel sheet, I will present you the data from the book, from the exercise, and you will need to use your Excel sheet to see what is happening over here. Okay, and we'll interpret the result together. And those people who are using their mobile phones to solve mobile phones for this particular class, what you are supposed to do, you have to sit quietly, and you can see our calculations, or you can start doing the calculations manually using your pen and paper. So that you can do. But if you are present in the classroom, then you have to work out something. You have to solve problems. If you are not interested in solving problems, then there is no need in being present in the class. Okay, so it is up to you. So I'm going to stop the share of this particular Excel sheet, and let us go back to my whiteboard that I was actually sharing with you in the previous session. And now as the chat box is open, so I want you to write your queries if you have any in the chat box. And if you do not have any queries, then you can leave the classroom, and I'm going to end my today's session. So if you have any queries, you can write in the chat box, and I am going to answer to that. So I'm waiting for your Yeah, someone is writing no queries. Okay, Dipanjan has no queries, but other students are present. Do you have any queries? Then you can ask me. You can write in the. Have you understood? Acha, okay, fine. Have you understood, students? Those who are responding, okay, okay. So if I'm able to upload this video, if I'm able to upload this video in the YouTube, I'm going to share the video with you in the Google Classroom. And in that case, you can revisit the entire class once again. Or screenshot, Anushka, you, I mean, haven't you written, Anushka, the points which I actually wrote on the screen? I mean on the board. If you have not done so, don't worry. If you have not done so, don't worry. I'm going to do several things. First of all, I'm going to upload one class note in the Google Classroom. Okay. I'm going to upload one note on. I'm going to upload one note on correlation coefficient in the Google Classroom this time, so that you can go through it. And then I'm going to upload the video in the YouTube. I will share the link with you. Then you can revisit the video there where the board works will be shown to you. And also, if I can do, I will try to send you the board work also in the Google Classroom. Try to. If it is saved in my system, then I'll be able to do so. Otherwise, not. Okay. So, but remember, in the next class, whenever it is, in the next class, you are going to sit with your Excel open. I am going to present exercise in front of you. You don't have to do manual calculations. I will show you we shall discuss the problem, the relevance, the background of the problem, and then you are going to use your Microsoft Excel to solve the calculation, to do the calculations. And if there is any interpretation, then we'll do the board work to justify the things. Okay. So don't have to write your student IDs again, because I have already saved the chat. Thank you for being patient, because in the beginning of the session, there was lots of disturbance regarding the network. And so I'm very much, I beg pardon. It is beyond the control of, it's beyond my control actually. Google Classroom code. Oh my God. Google Classroom code. Just a minute. Hold on, students. Just a minute. Google Classroom code you want. Okay. So I'm trying to give it to you. I actually sent the Google Classroom code to your coordinator. And